All right. What is up, everybody? Tom McGraw here with another episode of the Learn Rust Live series. Chapter 19 has one section left. We got one section left of Chapter 19, and then we're on to the final chapter, Chapter 20. I've been thinking about how I'm going to do this. We could do, hear me out, we could finish up Chapter 19, which is on macros. It's a little lengthy. And then we could start Chapter 20, like midway through. But I'm thinking, and hear me out, I'm thinking we just do 19. And we save 20 so that we can kick it off proper, do like a proper final chapter episode that isn't prefixed with Chapter 19. Because Chapter 19, whatever, it's advanced features, it's chill, it's no Chapter 20. And we do a special episode next week for Chapter 20. With the extra time we have today, we'll do 19. We'll do a little bit of review. Maybe we'll chat a little bit. Maybe we'll do a little content brainstorm for some other future content. I think we'll finish Chapter 19 today. We'll see what time it is. And we'll play it by ear. But I think starting Chapter 20 like fresh, like coming out with an episode like Chapter 20, it's all about Chapter 20, nothing about Chapter 19, just jumping in web server. I think that would be a little bit more fun. We'll play by ear. We got Albert in the chat. What up, Albert? Always hanging out. Love to see it. All right. Classic. You know what's coming next. You know, if you don't know, about to find out. The plugs. The videos. If you missed any of it, not a problem. Not a problem at all. It's all here on YouTube. Look at this. I've been even better about it too. I don't know if you noticed. I've gotten a little better at it. Last time we did the live stream on Tuesday, I had it up. Look at this. I had it up the same night. Maybe it was the next morning in HD. It comes up standard definition, but we had it up basically the same night. So we're doing all the production now on the same computer. None of this lollygag and stuff I was doing before. So we're going to get that up there as soon as possible. So after this stream, I'm going to start uploading it. That's how it works now. I do it, I upload it. So catch it on YouTube. If you've missed any of the previous chapters, they're all there. Everything up to Chapter 19, including the rustlings. More stuff to come. It's been really exciting. Also, I've said this a bunch of times, but want to say it again. I've been getting some awesome comments. People are loving the videos. It's really rewarding because I literally, like I've said before, I just take the stream and I just upload it. I cut out like the intro part, right? The waiting, but I'm not doing any editing. I could be putting a lot more effort into this. I know, but just the amount of feedback I've gotten just from what I have been able to do with my time has been awesome. So thank you so much for enjoying. I know it's a little rough watching a 2-hour stream, but hey, you can watch it at 2x speed, 1.5x speed. And I'm very surprised at how many people are watching these things. I mean, I'm not surprised. It's quality content. But of course, I'm going to get better. I'm going to try to make some more crisp YouTube-specific content because it seems like YouTube's where it's at. Twitch, I'm not going to lie, Twitch has been a little sparse. But YouTube has been killing it. So I might also try live streaming to YouTube as well in the future. But more for YouTube. And thank you for all the people hanging out. We have people... I asked it in the comments before, but I'll mention it again. If you've made it all the way to this video, put a comment and say, I've been here the whole time. We've had a few people say, just made it to this video, just made it. So really fun to see. And I'd love to start a project with any of you. Reach out. We had some people post some project ideas. More of that. Love to see it. But anyway, thank you so much for watching. It's been awesome. Again, a lot of people have subscribed, commented. I love to see that. That's great. Thank you so much. That helps me understand what people enjoy, and I'll put some more stuff out there. I'm having a lot of fun with it. Anyway, the Twitter. You got the Twitter. What do I need to say about this? Whatever, Twitter, whatever. You know what it is. GitHub, Learn Rust Live. That's where we're putting all the code here today. You can also catch some of my other repos here. We got the serverless API that we built. We got a fun little choose your own adventure builder. That kind of, I don't know if I finished that, but it's a pretty good one. And other fun stuff. Check that out. You always know we do it. We always do it. We do it because we couldn't be here without Steve Klobnik and Carol Nichols and anyone from the Rust community that contributed to making this book. We couldn't do it without this book. So Thank you so much for taking the time to write this book, all 20 chapters of it with the appendices. And it's been fun, and we're almost there. We've made it really far. I didn't know if we were going to do the whole book when we started. I knew we were going to do a few chapters and do some exercises and maybe pick up some stuff, but we've been grinding it. We're level 19. We're going to finish 19 tonight too. All right, so so just huge shout out again. And again, just thank you for watching. If you've been following along this long, if you've been keeping up with chapter 19, you're with us here. We're going to have a fun time. All right. What are we doing today? Let's do a quick recap, then we'll jump into what we're doing today. So quick recap. Last Tuesday, we did advanced features. We learned about unsafe Rust, why use it. Unsafe Rust is this quick summary. It's when you know as the developer that you trust code and Rust can't determine its safety, you can say, hey, this is unsafe code, and you can even wrap it in a safe API. So that was a huge portion of it. So we did that. We did advanced traits. So we used some advanced traits. Let me see if I can pull up the code so we can take a look here. Let's open up. Let's download the new Rust Analyzer. It's like a new version I don't know if you all noticed this. There's been like a new version every time we sign in on Tuesday here. So that's been pretty awesome. All right, so we have our chapter 19 advanced features. No, it's telling me no, that doesn't exist. Hold on, let's see what's going on here. What do we got? Oh, it's in projects, that's why. Projects, chapter 19. Let's open this up. So we had, there we go. Unsafe Rust, advanced traits. We did this, we had this like printer, remember, outline print. That was like, it printed like a decoration around the text. That was pretty cool. We did some stuff with, where we had traits. So we had a few different implementations. So we had a human. It was kind of like doing inheritance almost, where we had a human, and we implemented pilot for human, we implemented wizard for human, and they each had a fly function. And then we had the default fly, and we were able to see which ones were called. We did the same thing for animal. We had a dog, right? We made a puppy, right? So we did some stuff with traits. Then we did some stuff with types, advanced types. What did we learn with advanced types? Well, we learned about doing things like, let me go here. We learned about some really cool functional programming stuff, right? So advanced types, let's see, where do we put that? Advanced types, source, main. We had kilometers. It was just a type, basically a type enum, where we say kilometers is just an integer 32, right? And we can use that interchangeably where we would use an integer 32. So that was pretty straightforward. What else did we do with it? I thought we did some more with the advanced types. Maybe not. Maybe we just read through it. Or did we stop? Did we stop after we did? Maybe this is where we stopped off. No, because we did functions. So we read through this. Yep, we read through this. We did functions and closures. What do we do at functions and closures? Well, we learned about how we can use, we've learned about how we can use closures as inline anonymous functions, but then we also learned how we can use regular functions in the place of closures, right? So we had add one, it's a function defined out here, and we saw how we could pass that, right? So we had do twice, and what you have to end up doing is you end up having to wrap that function in a box, right? You have to have some indirection. So here we had this do twice. We're saying that do twice takes add one, which is a function. If you look at do twice, its arguments are a function and an integer 32. And so that's how we're able to pass. This is the signature for passing a function. We had returns closure, which is how you would return a closure, right? If you want to generate a closure, like create a function. We had status here and enum with status and value. And what do we do with that? Well, we have list of statuses. And we used our map functions, like a functional programming thing. If you use map, filter, reduce, we used map. And what do you pass map? Well, you pass it a function, right? So what do we pass? We passed toString in this case, so it was showing how you can pass a function to map to an iterator. Here we created a range, we mapped over it. What did we pass? We passed status.value. So here's what value is. It just wraps an unsigned 32-bit integer. So playing around with functions and closures. And today we're going to do macros. So let's jump in a little bit. All right. We've used macros like println throughout the book. Yeah, we've used it literally in every chapter probably, right? That's how we've been printing stuff. You can see it here. And how do we know it's a macro? We know it's a macro because the exclamation point. That's what's noting that it's a macro. And you can see when we hover, it says there, macro rules, println, macro export. So it shows you that it's a macro, right? So we've used println throughout the book. But we haven't fully explored what a macro is and how it works. The term macro refers to a family of features in Rust. Declarative macros with macro rules, which we saw when we hovered there, and 3 kinds of procedural macros. So there's the declarative macros with macro rules and procedural macros. The first one is custom derived macros that specify code added with the derive attribute used on structs and enums. We've seen this, right, with derive debug and the test. So we've used derive. We use derive debug when we're outlining some of our functions, right, to indicate that it has the debug trait. So if we wanted to print it in a particular way, right? Attribute-like macros that define custom attributes usable on any item, and function-like macros that look like function calls but operate on the token specified as their argument. We'll talk about each of these in turn, but first, let's look at why we even need macros when we already have functions. All right, what is the difference between a macro and a function? So if you notice, like right for println, we could have just probably called a function. But of course we know because it has an exclamation point, it's a macro. So let's see why. What's the benefit of having a macro instead of just a basic function? Fundamentally, macros are a way of writing code that writes other code. Some people call this, it says right here, which is also known as metaprogramming. This is a common concept. There are a few languages that support metaprogramming. For example, one of my favorite languages right now, Elixir, allows for metaprogramming as well. It gives you the ability to write code using code, so you can generate different bits of code. So that's pretty cool. In Appendix C, we discussed the derive attribute, which generates an implementation of various traits for you. We've also used the println and vector macros throughout the book. All of these macros expand to produce more code than the code you've written manually. So it's basically like shorthand. You can think of it as syntactic sugar on top of some other functionality. Metaprogramming is useful for reducing the amount of code you have to write and maintain, which is also one of the roles of functions. However, macros have some additional powers that functions don't have, right? A function signature must declare the number and type of parameters the function has. For example, if we're looking at a function like add1 here, we are declaring the parameter. We're saying it has one parameter, and it's of type signed 32-bit integer, right? So that's how you define a function. Macros, on the other hand, can take a variable number of parameters. We can call println hello with one argument or println hello name with 2 arguments. Also, macros are expanded before the compiler interprets the meaning of the code. So macro can, for example, implement a trait for a given type. A function can't because it gets called at runtime and a trait needs to be implemented at compile time. So macros are done before the code is compiled. They're expanded. So that's pretty cool. The downside to implementing a macro instead of a function is that macro definitions are more complex than function definitions because you're writing Rust code that writes Rust code. Due to this indirection, macro definitions are generally more difficult to read, understand, and maintain than function definitions. Makes sense. You write them once to expand out to some long form code. We don't want to use them everywhere because they're verbose, right? The implementation is verbose. Another important difference between macros and functions is that you must define macros or bring them into scope before you call them in a file. As opposed to functions, you can define anywhere and call anywhere. Pretty cool. Declarative macros with macro rules for general metaprogramming. The most widely used form of macros in Rust is declarative macros. These are also sometimes referred to as macros by example. Macro rules macros. I don't know why they call them macro rules macros. Like it looks like it's saying macro rules, but I don't know. or just plain macros, of course. At their core, declarative macros allow you to write something similar to a Rust match expression. As discussed in Chapter 6, match expressions are control structures that take an expression, compare the resulting value of the expression to patterns, and then run the code associated with the matching pattern. We call that matching code the arm, right? Different arms of the functions. Macros also compare a value to patterns that are associated with particular code. In this situation, the value is the literal Rust source code passed to the macro. The patterns are compared with the structure of that source code, and the code associated with each pattern, when matched, replaces the code passed to the macro. This all happens during compilation. So, what does that all mean? Let's dive in here. To define a macro, you use the macro rules construct. Let's explore how to use macro rules by looking at how vector macro is defined, which we've used a bunch of times. Chapter 8 covered how we can use the vector macro to create a new vector with particular values. For example, the following macro creates a new vector containing 3 integers. All right, so you know what we do here. I'm going to go ahead and I'm going to pop into the top right to get out of your way. And what we're going to do is we're going to create a new folder for this. So we're just going to do cargo new macros. We're going to go open up macros. All right. We're going to go to source main, and let's just type that in here. So we're going to do let v, and we're going to declare it's a vector of unsigned 32-bit integers. Let me zoom in a level there so you can see that. And I'll also go down here because I'm in your way, even though I tried to get out of it. All right, so we have a vector of unsigned 32-bit integers, and we're just going to declare it as the vector macro, as we've used many times, right? We could also use the vec macro to make a vector of 2 integers or a vector of 5 string slices. We wouldn't be able to use a function to do the same because we wouldn't know the number of types, the number or type of the values up front. So we can use this to, we can give it, 4, 5, right? We can change it's not complaining about the number of arguments. We could even change the type. As long as they're all the same type, right? We could change the type. And that's because this is a macro, right? So we wouldn't be able to do the same thing with the function, right? Because we wouldn't know the number of type up front. So here below it says, below shows a slightly simplified definition of the vector macro. So here's how they've defined it. So let's type it out. So we have, let's type it up here. So we have macro rules, and then look, it gives us this awesome placeholder. You saw it auto-completed that for me? Let me show that again. Look at that. And what are we going to call the macro? This is the name. And then here is the cool part. And I can already see kind of what's going on. It's going to take an expression. Let's copy it. Let's copy what they have here. So, and then we'll dive, I'm sure we'll dive in and figure out what all of this means. It looks like something kind of like a syntax, maybe like a regular expression, right? Or something. And we'll find out. But so I think what we're saying here is this represents kind of the types of things you can pass it, right? Because it's stars, it can have n number of arguments, right? So this is like kind of representing what can be passed here. I've seen stuff like this before. I don't remember if it was in this book or maybe it was in, you know where it was? I think it was in Rustlings, potentially. I think we did this in Rustlings. But let's see, because it does look semi-familiar. Okay, what do we do next? So here they're creating a block. The next thing they're doing is creating a block inside here, and then a mutable variable called tempVec, which equals vector new. The standard, this is again the non-macro version, the standard vector new. Then there's some $, and here we're doing tempVec.push $x star. And then here we're returning tempVec. All right, I have no idea what's going on here. Let's find out. The actual definition of the vec macro in the standard library includes code to pre-allocate the correct amount of memory up front. That code is an optimization that we don't include here to make the example simpler. So they're showing you what a very simple implementation of the vector macro would look like. And here it's saying, I guess we need to export it, right? So if we do, and we need to do this, And this needs to be temp vec. And there we go. It stopped complaining. Okay, the macro export annotation indicates that this macro should be made available whenever the crate in which the macro is defined is brought into scope. Without this annotation, the macro can't be brought into scope. When we start the macro definition with macro rules, and the name of the macro we're defining without the exclamation mark, right? So when we start the macro with definition macro rules, and the name of the macro we're defining without the exclamation mark, the name in this case, vec, is followed by curly brackets denoting the body of the macro definition. So this curly brackets, this is the body of the macro definition. The structure in the vec body is similar to the structure of a match expression. Here we have one arm with this pattern. So they're saying it looks like a match expression where this is the single arm is this one, right? Followed by a fat arrow and the block of code associated with this pattern. This is actually literally a block, right, with the curly braces. If this pattern matches, the associated block of code will be omitted, right? It gets returned, omitted. That's key. This block of code will be omitted. Given that this is the only pattern in this macro, there's only one valid way to match. Any other pattern will result in an error. More complex macros will have more than one arm. So this is very simple. It has one arm. It has to match this expression here. And if it does, it omits this. So basically what happens is this code, right, it ends up getting expanded to that, right? Valid pattern match syntax in macro definitions is different than the pattern match syntax covered in chapter 18 because macro patterns are matched against Rust code structure rather than values. Let's walk through what pattern pieces in listing 1928 mean. For the full macro pattern syntax, we can check out the reference. All right, so we're going to figure out what this part means. This is what they're talking about, the pattern matching syntax. That's what we're going to figure out. All right, first, a set of parentheses encompasses the whole pattern. That's clear, right? Here. Parenthesis, right? A $ is next. Oh, you know where we read this? When we did rustlings, we jumped ahead to this chapter, and you all remember if you followed, you remember when we did. That's why it sounds familiar at this point because we saw this. We jumped to this chapter to get a quick read on it, and we read this. We read these paragraphs. Maybe I'll pull it up. Maybe I'll pull up the video clip. But yeah, that's why it's familiar. Pretty cool. Okay, anyway. So the $ is next, followed by a set of parentheses that captures values that match the pattern within the parentheses for use in their replacement code. Let's go slower. Let's go slow through this. So the $ next. Next is the set of parentheses that captures values. So the set of parentheses captures values that match the pattern within the parentheses for use in the replacement code. Within the $ parentheses is $x expr x expression, which matches. So this thing here, this expression here, this matches any Rust expression and gives the expression the name $x. Okay. This right here, let me just put a space so it looks exactly like it does in the thing there. This matches any Rust expression. That's what this does, and gives and assigns it to $x, and that's probably why we're able to use it there, right? Why did we choose the name $x? I will never know. Maybe I will. Maybe they'll tell us. The comma following the $ parentheses. So that's part one. So part one's that part, right? Then there's a comma, right? And then there's an asterisk. So the comma following the parentheses indicates that a literal comma separator character could optionally appear after the code that matches the code in the $ parentheses. And you can see here in our macro, we are using a comma. So it's saying commas, an optional comma can appear right there, right? Makes sense? Okay, so the asterisk now in this case specifies that the pattern matches 0 or more of whatever precedes the asterisk. So we're saying there can be 0 or more of this, right? And we know that. 1, 2, 3, and it can go on right forever. When we call this macro vector 1, 2, 3, The $X pattern matches 3 times with the 3 expressions, 1, 2, and 3. Right? So this expression matches 1, 2, and 3. It captures those values in $X, and then it pushes it onto this vector. Pretty cool. Now let's look at the pattern in the body of the code associated with this arm. Temp vec push within the $* is generated for each part that matches $. So for every expression, so it's going to create n of these, right? So you could imagine, let me just show you. What it actually ends up expanding to could look something like, what that expands to would probably look something like this. In this case, the first one, x would be 1, right? In this case, x would be 2, and in this case, x would be 3. So this code here expands to the code that I have. I'm going to comment out here. So this code here will expand to this code here. And the way that that works is we're grouping it. Again, we're grouping it here. We're saying this expression star is however many times, right? However many times that this appears, this expression appears. Pretty cool. So it generates each part that matches the $ parentheses in the pattern 0 or more times, depending on how many times the pattern matches, essentially. The $X is replaced with each expression matched. When we call this macro vector 1, 2, 3, the code generated that replaces the macro will be the following. So that's what we saw. That's what we commented out there. So pretty cool. So this gets replaced. So, you know, syntax that you just have to know and remember. That's why we're doing the book, right? But pretty cool. We define a macro that can take any number of arguments of any type and can generate code to create a vector containing the specified elements. There are some strange edge cases with macro rules. In the future, Rust will have a second kind of declarative macro that will work in similar fashion but fix some of these edge cases. After that update, macro rules will be effectively deprecated. Ooh, interesting. I wonder when that's happening. With this in mind, as well as the fact that most Rust programmers will use macros more than write macros, we won't discuss macro rules any further. To learn more about how to write macros, consult the online documentation or other resources such as the Little Book of Rust Macros. All right. They taught us it, and now they're like, you're probably not going to use it, and it'll be deprecated. Great. All right. Procedural macros. The second form of macros is procedural macros, which act more like functions and are a type of procedure. Procedural macros accept some code as input, operate on that code, and produce some code as an output rather than matching against patterns and replacing the code with other code as declarative macros do. So let's go over that again. That's important, right? Procedural macros, I mean, everything's important, but procedural macros accept some code as input, operate on that code, and produce some code as output rather than matching against patterns and replacing code with other code. The 3 kinds of procedural macros are custom derived, attribute-like, and function-like. They all work in a similar fashion. When creating procedural macros, the definitions must reside in their own crate with a special crate type. This is for complex technical reasons that we hope to eliminate in the future. Pretty cool. Using procedural macros looks like the code in listing 1929, where some attribute is a placeholder for using a specific macro. All right, let's try this. We're going to use proc macro. What is this? Procedural macro. Oh, it's a different crate. So we need to install that crate. All right, so we'll do that in a second, but let's do this. Let's say use some attribute pub function, some name, input, token stream, output is token stream And that's it. So the function that defines a procedural macro takes the token stream as an input and produces the token stream as an output. The token stream type is defined by the proc macro crate that is included with Rust and represents a sequence of tokens. Well, is it included? Because it's saying it's not. Oh, I guess we don't need to hit use on it. But token stream, it's saying can't find token stream. So maybe we have to do use proc macro dot token stream. Let's see, where's token stream defined? Maybe it'll help me. Let's search it. Rust use token stream. Proc macro token stream. Huh. We are doing that. Let's see. I'm not sure. The function that defines a procedural macro takes the token stream as input and produces the token stream as output. The token stream is defined in the proc macro crate that's included with Rust and represents a sequence of tokens. This is the core of the macro. Okay. The source code that the macro is operating on makes up the input, token stream, and the code that the macro produces is the output, token stream. The function also has an attribute attached to it that specifies which kind of procedural macro we're creating. We can have multiple kinds of procedural macros in the same crate. Let's look at the different kinds of procedural macros. We'll start with a custom derived macro and then explain the small differences or dissimilarities that make the other forms different. All right, I'm going to comment this out because this didn't seem to do anything. How to write a custom derived macro. Let's create a crate named hello macro that defines a trait hello macro. So we're going to create a new crate. So we'll do cargo new hello macro. Open that up. All right. So we created a crate called hello macro that defines a trait named hello macro with one associated function named hello macro. Rather than making our crate users implement the hello macro trait for each of their types, we'll provide a procedural macro so users can annotate their type with derived hello macro to get a default implementation of the hello macro function. The default implementation will print hello macro, my name is type name, where type name is the name of the type on which this trait has been defined. In other words, we'll write a crate that enables other programmers to write code like the listing in 1930 using our crate. So this is how we'll want them to use it. They're going to import hello macro, hello macro, hello macro derive, hello macro derive, derive hello macro, struct pancakes, and then pancakes can use hello macro. The code will print hello macro, my name is pancakes when we're done. The first step is to make a new library crate like this. They wanted a library crate. Okay, let's go ahead and just change. Well, we can do it really easily. We can just remove this one. Oh. All right, so we'll do rm-rf hello macro, and we'll do cargo new hello macro -- lib. All right. Let's close that. Code hello macro. All right, there's our source, there's our lib. So now we have a library crate. Next, we'll define the hello macro trait and its associated function. Source lib, so let's define that trait. Public, let's do it up top actually. Let's do it up here, let's get rid of that, There you go. Public trait hello macro. And what do we have to implement for this trait? Well, function hello macro. We have a trait and its function at this point, and our crate user could implement the trait to achieve the desired functionality like so. So they would import hello macro, struct pancakes, and then they would have to implement hello macro using implementation block, right? However, they would need to write the implementation block for each type they wanted to use with hello macro. We want to spare them from having to do this work. Additionally, we can't yet provide the hello macro function with the default implementation that will print the name of the type and the trait is implemented on. Rust doesn't have reflection capabilities, so it can't look up the type's name at runtime. We need a macro to generate code at compile time. So the next step is to define a procedural macro. At the time of this writing, procedural macros need to be in their own crate. Eventually, this restriction will be lifted. The convention for structuring crates and macros crates is as follows. For a crate named foo, a custom derived procedural macro crate is called foo derive. Let's start a new crate called hello macro derive inside our hello macro project. Okay. So inside here, we're going to do cargo. So first we're going to go into hello macro, and inside hello macro, we're going to do cargo new hello macro derive lib. And there we have another one. Our two crates are tightly related. So we create the procedural macro crate within the directory of our hello macro crate. If we change the trait definition in hello macro, we'll have to change the implementation of the procedural macro and hello macro derive as well. The two crates will need to be published separately, and programmers using these crates will need to add both as dependencies and bring them both into scope. We could instead have the hello macro crate use hello macro derives as a dependency and re-export the procedural macro code. However, the way we structure the project makes it possible for programs to use hello macro even if they don't want the derived functionality. We need to declare the hello macro derive crate as a procedural macro crate. We'll also need functionality from the sin and quote crates, as you'll see in a moment. So we need to add them as dependencies. Add the following to the cargo toml for hello macro. So again, we're going to need functionality from the sin, syn, and quote traits. So we're going to add them to our cargo toml. All right, let's open our cargo toml. And it's going to be the cargo toml for the derive. So it's this one here. And we're going to add syn equals 1.0 and quote equals 1.0. To start defining the procedural macro, place the code in listing 1931 into your source lib file for the hello macro derive crate. Note that this code won't compile until we add the definition in the implement hello macro function. So we're basically going to copy this into the lib from, let me just move that over here, right? We're going to paste this into source lib file in the hello macro derive crate. So that's this file. So let's go ahead and paste this. So we have extern, let's see what it does first. Extern crate proc macro, use proc macro token stream. That was what we missed before. We didn't do the extern crate thing. Use quote, and syn. And then we have our proc macro derive. So let's copy this, paste it here. So we have public function hello macro derive. It takes a token stream, returns a token stream. So we saw that's a procedural macro. Construct a representation of Rust code as a syntax tree that we can manipulate. Pretty cool. Build the trait implementation. Okay. Notice that we split the code into the hello macro derive function, which is responsible for parsing the token stream, and the implement hello macro function, which is responsible for transforming the syntax tree. This makes writing a procedural macro more convenient. The code in our outer function, hello macro derive in this case, will be the same for almost every procedural macro crate you see or create. The code you specify in the body of the inner function, implement hello macro, in this case, will be different depending on your procedural macro's purpose. So implement hello macro, right, is going to have the actual logic for this, where this is kind of generic, right? We've introduced 3 new crates, proc macro, syn, and quote. The proc macro crate comes with Rust, so we didn't need to add that to the dependencies in the cargo toml. The proc macro crate is the compiler's API that allows us to read and manipulate Rust code from our code. Pretty cool. The SYN crate SYN parses Rust code from a string into a data structure that we can perform operations on. The quote crate turns SYN data structures back into Rust code. These crates make it much simpler to parse any sort of Rust code we might want to handle. Writing a full parser for Rust code is no simple task. So the hello macro derive function will be called when a user of our library specifies derive hello macro on a type. This is possible because we've annotated the hello macro derive function here with proc macro derive and specified the name hello macro, which matches our trait name. This is the convention most procedural macros follow. The hello macro derive function first converts the input from a token stream to data. Right, so that's happening there. To a data structure that we can interpret and perform operations on. This is where SYN comes into play. The parse function in SYN takes the token stream and returns a derive input, struct representing the parsed Rust code. The listing below shows the relevant parts of the derived struct we get from parsing struct pancakes string. Yep. The field of the struct show that Rust code we've parsed is a, oh wait, actually do we need to, yeah. The fields of this struct show that Rust code we've parsed is a unit struct within the indent identifier, meaning the name of pancakes. There are more fields on this struct for describing all sorts of Rust code. Check the SYN documentation for derived input for more information. All right. Soon we'll define the implementation hello macro function, which is where we'll build the new Rust code that we want to include. Before we do, note that the output for our derived macro is a token stream. The return token stream is added to the code that our crate users write. So when they compile their crate, they'll get the extra functionality that we provide in the modified token stream. Got it. You might have noticed that we're calling unwrap because the hello macro derive function, so unwrap can cause the hello macro derive function to panic if the call to SYN parse function fails here. That makes sense. It's necessary for our procedural macro to panic on errors because proc mac derive functions must return a token stream rather than a result. So it can't just return like a result type, right? To conform to the procedural macro API. We've simplified this example by using unwrap. In production code, you should provide more specific error messages about what went wrong by using panic or expect. Now that we've had the code to turn the annotated Rust code from a token stream into a derived input, which is this here, right? That's this. Just went over it. Let's generate the code that implements the hello macro trait on the annotated type. Okay, so let's do that. So in our hello macro derive, we're going to have this new function block here, function implement. It's the function we're using here, right? So we're just going to, we need to just use it and make it work with that API. Implement hello macro. What's it going to take? It's going to take an AST, an abstract syntax tree, right? So it's going to take an AST, and the type is of syntax, right? SYN derive input. Sorry, capital D there. And it's going to return a token stream. So here we're going to do let name equal from the AST dot identity. We're going to do let gen equal quotes. Implement. So this is, we're actually generating the implementation block, right? That's why this block here looks like a regular implementation block. Hello macro. And we don't know the name of the module. That's where this comes in. That's where this generator comes in, right? We're going to use name here. We're going to template it in. Hello macro for name function hello macro. And then what are we going to do? We're going to print ln. And this is just the default implementation of the hello macro, right? That's what we're doing here. My name is Stringify. And then again, we can template in name here. Pretty cool. We get an identity struct instance, so let's break it down. We get an identity struct instance containing the name identifier of the annotated type using AST ident, right? The struct in listing 1932 shows that when we run the implementation hello macro function on the code in listing 1930, which is, this is 33. Above here we have 31. There we go. This is the way that they want to use it here. Got it. So the struct in listing 32 shows that when we run the implementation hello macro, right, function on the code, the identity we get will have the identity field with a value of pancakes. I like pancakes. They're delicious. Thus, the name variable in listing 1933 will contain the ident struct instance that, when printed, will be the string pancakes, the name of the struct in listing 1930. The quote macro lets us define the Rust code that we want to return, right? That's this part here. In fact, actually, did I leave off a... There we go. So that's why this looks like an implementation block, right? That's the code we want to return. The compiler expects something different to the direct result of the quote macro execution, so we need to convert it to a token stream. We do this by calling the info method, or into method, right? Actually, where is that happening? Which consumes the intermediate representation and returns the value of token stream type. Where do we call into? Did I miss something? No. Oh, yeah, I did miss something. The last part, gen.into. Ooh, good catch. Good catch. Okay, there we go. We do this. So what do we do by calling the into method? So the compiler expects something different to the direct result of the quote macros execution, which is a token stream. So we need to convert it to a token stream. We do that by calling gen.into, which consumes this intermediate representation and returns a value of the required token stream type. The quote macro also provides some very cool templating mechanics. We can enter hashtag name and quote will replace it with the value in the variable name. You can even do some repetition similar to the way regular macros work. Check out the quote creates doc for a thorough introduction. Pretty cool. We want our procedural macro to generate an implementation for a hello macro trait for the type the user annotated, which we can get by using hashtag name. The trait implementation has one function, hello macro, whose body contains the functionality we want to provide, printing hello macro, my name is, and then the name of the annotated type. The Stringify macro used here is built into Rust. It takes a Rust expression such as 1 plus 2, and at compile time returns the expression into a single string, such as quotes 1 plus 2. This is different than format with an exclamation point or print ln with an exclamation point macros, which evaluate the expression and then turn the result into a string. So they evaluate it first and turn it into a string. So in this case, it would be string 3, right? There is a possibility that the name input might be an expression to print literally, so we use Stringify. Using Stringify also saves an allocation by converting name to a string literal at compile time. At this point, cargo build should complete successfully in both hello macro and hello macro derive. Let's hook up these crates to the code listing 1930 to see the procedural macro in action. Okay, so let's go ahead and hook that up to that code. So that code in section 30 is up here. I believe it's right here. All right, I'm gonna put this in our library crate. All right. Okay, what does it say? Unresolved import hello macro. Interesting. Because I need this part. I copied the wrong one. So here we have use hello macro derive hello macro. Let me make sure that that's what that's called there. Hello macro derive. Let me make sure we have the whole thing here. Implement hello macro. Okay, so here it says cargo build should complete successfully in both hello macro and hello macro. Let's hook up these crates to the listing 1930. We need to add hello macro and hello macro derive as dependencies in the pancake crates cargo toml. If you're publishing the versions of Hello Macro and Hello Derived to crates.io, they would be the regular dependencies. If not, you can specify them as path dependencies as follows. So let's add this to... Oh, is the pancakes one separate? Is that why? And then we're actually just using Hello Macro. I think that's what it is. Yeah, pancakes crate. Ah. So let's take this out. I wonder what was supposed to go in here then. Hold on, let's break it down. So we have Hello Macro Derived lib. Okay, that's good. The cargo toml. Okay, this is Hello Macro here. No, that's in source lib. Yeah, so in source lib we have public trait, pub trait, hello, pub trait, hello macro, function hello macro. All right. Let's create a crate named Hello Macro that defines a trait named Hello Macro with one associated function named Hello Macro. Rather than making our crates, users import Hello Macro trait for each of their types, blah, blah, blah. The default implementation will print blah, blah, blah. In other words, we'll write a crate that enables another program to write code like listing. Okay, so let's create a new crate for this. Let's do it outside here. Let's do cargo new pancakes. And it looks like it's just going to be a binary crate. And so let's open it up. So for pancakes, we are going to do, we have our main here, and we're just going to copy this. We're going to need to update our toml to use those dependencies. Hello macro equals path equals, let's see, it's let's see, if we're inside pancakes, it's // yeah, so this is right. I'm just going to copy this, save that, put the code from listing 30 into source main and run cargo run. It should print hello macro, my name is pancakes. Let's see what's going on here. Unresolved import. Well, that just might be because we have to. There we go. Everything looks good. Let's run cargo run. Waiting for file lock on package cache. Interesting. Let's try it again. Ah, that's happening here. Down here. Let's wait for that. We'll continue while we wait for that. Oh, there we go. Building. Oh, we got an issue with our source lib and hello macro derive. Let's take a look at that. Not this. Let's see. This one, not this one. Let's exit that one. I think it's this one. Nope. It is, let's see. Code hello macro. All right, let's take a look here. So we have our derive. What is it talking about here? It's saying there's some error here. I don't see anything. Let's try that again. Let's close this one. All right, so let's see what it says. It says, let me move out of the way here. It says, proc derive hello macro. The proc derive macro attribute is only available crates of the proc macro crate type. And then here it says expected struct proc macro token stream found unit type. So let's take a look at what's going on. That's in the hello macro derive. So let's see, it's expecting that, but it's only getting union type. So let's take a look at where we have that code. There's this part, that's the implementation. And this part should look like this. That should be right. Okay. Let's try it again. Let's clear it and let's do cargo run. Okay, so it's saying, now it's saying could not compile hello macro derive. Attribute is only usable crates of the proc macro crate type. Interesting. Oh, that's this. Look, we forgot a major part there. Skimmed over it. Okay, so in the cargo lock or cargo toml, we need to specify lib proc macro equals true. This is not here. It would be in this here. Let's go here. Let's go to the toml, and then we need to do lib proc macro true. Now let's try it. All right, let's see what happens now. Cargo run. There we go. Hello, my name is Pancakes. Awesome. All right, attribute-like macros. Attribute-like macros are similar to custom derived macros, but instead of generating code for the derived attribute, they allow you to create new attributes. They're also more flexible. Derive only works for structs, and enums attributes can be applied to other items as well, such as functions. Here's an example of using an attribute-like macro. So you have an attribute named route that annotates functions when using a web application framework. Route get slash. The route attribute would be defined by the framework as a procedural macro. The signature of the macro definition function would look like this. So defines a route, right? Get slash. So the proc macro attribute would have function route. It would take an attribute token stream, an item token stream, and return a token stream. So you can think of this as a token stream. This is a token stream, right? The attribute and the item. Here we have two parameters of type token stream. The first is for the contents of the attribute, the get slash part. So sorry, that's this whole part. The second is the body of the item the attribute is attached to. Interesting. The body that it's attached to. In this case, it's the function index bracket and the rest of the function's body. Other than that, attribute-like macros work the same way as custom derived macros. You create a crate with the proc macro crate type and implement a function that generates the code you want. Function-like macros. Function-like macros define macros that look like function calls, similarly to macro rules macros. They're more flexible in functions. For example, they can take an unknown number of arguments. However, macro rules macros can be defined only using the match-like syntax we discussed in the section above. Function-like macros can take a token stream parameter, and their definition manipulates that token stream using Rust code, as the other two types of procedural macros do. An example of a function-like macro is the SQL exclamation point macro that might be created like so. Oh, cool. Creating a SQL statement. This macro would parse the SQL statement inside it and check that it's syntactically correct, which is much more complex processing than a macro rules macro can do. The SQL exclamation point macro, or just the SQL macro for short, will be defined like this. Proc macro, it takes a token stream, it returns a token stream, and then of course it does the validation. The definition is similar to the custom derived macro signature. We receive the tokens that are inside the parentheses and return the code we want to generate. Summary. Woo! Now you have some Rust features in your toolbox that you won't use often, but you'll know they're available in very particular circumstances. We've introduced several complex topics so that when you encounter them in error message suggestions or in other people's code, you'll be able to recognize these concepts and syntax. Use this chapter as a reference to guide you to solutions. Next, we'll put everything we've discussed throughout the book into practice to do one more project. Woo! All right, that is it for chapter 19. Now, we're going to save chapter 20. We're going to start it next week. This way we can just jump in chapter 20 fresh, split up the videos, split up the thing, have a focus, do a little celebration for the final chapter. Maybe we'll even get started longer. Maybe we'll do a 3-hour stream. Maybe we'll do a longer stream. That might be the way we do it. But yeah, next week we're going to be building our final project. Let's take a look a little bit. Let's get a little preview for what we're in for, right? So we're going to do our final project. It's going to be a basic web server. This is a common project. This is actually one of the first things they have you do when you, in one of the Elixir courses I did. You hear me talk about Elixir a lot. It's because I use it a lot. Love it. But it's a very good way to learn a language and get to know it, some of its patterns and how to use them. So I'm excited for this. And if you look at the breakdown, we're going to start by building it single-threaded. Classic. Single-threaded, what do we mean by that? It takes a request, it blocks, it handles that request. If you shoot 2 requests, it handles them one at a time. Then we're going to turn it into a more useful, typical server, multi-threaded, right? So we're going to handle requests, and it'll spin up a new thread for each of those requests. So I'm excited for that. And it's definitely a long chapter. So we might do, maybe we'll do like, look at how long this is. Look at how long. Whoo! Whoo! It's a long one. And then the last part. I don't want to spoil it. So maybe we'll do a longer stream next week. But yeah, I want to hold off on starting it. I'm also getting a little tired tonight. But yeah, let's just take a break, a pause real quick, and look at how far we've come. We've done 19 chapters of this book. This is no small task. You might say, oh, it's just a book, you just read it. But we've been reading it along. We've been coding alongside it. We've been doing exercises as we go. We even took a break to do rustlings. It's all here. Look at how far we've come. Look, I look like a child back here. I haven't aged a day. Wow. But look at this. We started there. I thought it would be a cool thing. We started out. It is a cool thing. Look, we went through. Look how much we've done. I wore a hat. In this one. But look, we've made it to chapter 19. It's taken quite a few weeks, but it's been a lot of fun. And we're going to end it strong next week with chapter 20. I'm very excited. If you haven't caught up, now's the time to do it. Ahead of chapter 20. Catch up, watch it on 2x speed, whatever you got to do. Read the book yourself, ignore me, that's fine. Let's just do chapter 20 together. It's going to be fun. If you're watching on YouTube, now's the time to join that Twitch stream. Check it out live because it's going to be fun. We're going to be working on this. Again, it's Tuesdays, 9 p.m. to 11 p.m. I will keep you posted if you follow on Twitter. There will be a shout out. Maybe we'll do something special. Maybe, like I said, we'll start earlier. We'll do a 3-hour stream. Maybe we'll do like an 8 to 11. Maybe we'll do a 9 to midnight. Maybe we'll go crazy late night. Get the Red Bulls out, the G Fuel. I got some G Fuel. Get the G Fuel out and just go. Start coding it, That chapter 19 was a little boring. I was getting a little sleepy. I don't want to go from that into chapter 20. I want to come into chapter 20 with like the hype, full hype for chapter 20. So that's what we're going to do next week. So follow on Twitter. This way you're updated. of what's going on. I'm going to post the code we did here today on Learn Rust Live, and this episode will be going up. It'll be up by tomorrow morning. Again, I've been trying to put it up early. So yeah, so we're going to end it a little earlier today. It's just past 10, so we did a little half stream, an hour, but that's because next week is going to be hype. We're going to start chapter 20. We don't want to start it halfway through. We're going to give it its full due, its full attention. Once again, shout out Steve Klobnik, Carol Nichols for making this amazing book. Couldn't be here without you. Thank you to you too. Shout out to anyone from the Rust community who made this book. We are literally one chapter away from finishing this book. And I think we could pretty much call ourselves Rustaceans. We're going to have to build some projects. We're going to have to contribute maybe, but I'm pretty excited about that. And we'll see. We'll see where it takes us. After we do chapter 20, we're going to feel pretty strong. We're going to feel pretty big. We're going to be like full Rustaceans, right? So we're going to want to take on some other projects. So we'll kind of cross that bridge when we get there and see what we end up wanting to do. Leave some comments, ask some questions in the comments section below, and thank you again for watching. If you're on the live stream, thank you for being here. Thank you for being in the chat, and we will catch you next week for the final chapter in what has been an amazing journey of the Rust programming language. Tune in, and we'll see you there. Have a good night.